Okay, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? It would also be skewed right, I think.
Yeah.
I remember thinking when we were watching the videos that I was like, if it isn't going to be a normal distribution, I don't understand it as much, because they kept talking about only if it was normal. So
yeah.
But I think it just matches the parent. So when you're taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? Would that be right skewed or normal? Because if it's the bigger the population, the more likely it is to be normal, right?
Yeah, it's bigger, so I think it would be normal.
Be normal? Okay.
Yeah.
I really like that we have 2 chances on these quizzes. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? That would still be normal, right?
Mm-hmm.
Okay. When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? That would also be normal.
Yeah, that is pretty.
Okay. When would the distribution of means be normally distributed? Normally distributed and the sample size is small, that would be normal.
Mm-hmm.
Normally distributed and the sample size is large. And then the right skewed, but the sample size is large. So just not the third one with the small.
Yeah, because if it was large, the sample size.
Yeah.
Yeah.
Okay. So the first one, second one, last one. Which of the following is the best explanation of the central limit theorem?
Is it the third one?
I think so. That was the one that I was confused on, like differentiating the two, because the other one is just that, like, the more whatever you call them, the more example samples or whatever you have, the more likely you are that like you're with the population. But then I didn't understand the central limit one as much.
I think that was the third or fourth.
Third or fourth, right?
Yeah.
Because the book.
I think it's the third one. I think I have it here in my notes.
Okay.
Supplement, yeah, just closer to the population.
Then it'll be closer to the mean. Yeah, that sounds right. Following information for the next 4 questions. What is the mean distribution of sample means? So in that case, it would just be 10, right?
Mm-hmm. Yeah, because
it's only one of them. The standard deviation would be, I'm gonna have to calculate that one.
6.
Oh wait, the standard deviation is already on there. It would just be 6. And then the sample size is large. What would be the shape of this? Normal?
Yeah, I think since it would be larger than the mean. Yeah.
If it's big, then that's the guess, right?
Yeah. We can always try the second time.
Yeah. Okay, we'll go with normal. And then what theorem would justify your response to the last question? That would be the law of large. No, that would be the central limit theorem, right?
I think so, yeah.
Okay.
Oh.
Okay.
I think it'd be the law of large numbers.
The law.
Wouldn't it? Because as it draws closer.
But that
the sample
is
size
that it
increasing.
makes it like more accurate according to the population, right?
Oh yeah, that's right. Yeah.
I still don't understand the central limit theorem, but I think I know that it's not the law of large numbers. So,
Yeah.
okay, guess we can go ahead and submit that and see how we did. Okay.
8.
So we got that standard deviation wrong, and then the central limit theorem because we apparently don't understand. Okay. So let's take this again.
So 3 was skewed right. 4 was normal, right?
Yeah, 4 was normal. And 5 is normal as well. 6 is normal.
7 was everything but the second.
Mm-hmm.
So then for 8, it would just be the last one then.
The sample size is just shape of the distribution of samplings. I think so. I mean, that's what we had narrowed it down to, right? It was the third one or the fourth one.
Yeah.
So I think so. And then 9 was 10, and 10 we got wrong. So the standard distribution, standard deviation of the distribution. Yeah, and it has the population standard deviation. So is that the one that you have to do is it the mean? Where'd it go? The standard deviation over the square root of the number.
Yeah. Mm-hmm.
That's what it is. I just skipped a step. So 6 over square root of 36. Did you guys get 1 for the standard deviation?
Mm-hmm.
And then 11 was normal, and 12 was the central limit there.
Yeah.
All right. Did you have any input, Andrea, before we leave you? The fourth one on that one that has the 4, yeah, it was all of them except for the sample size was small one. Okay. Now we're just going to hope we're right on that central limit theorem question. Looks like we were good. Did we all get 100%?
Yeah. Cool.
Okay. Perfect. Did you guys have any questions on the reading before I stop the broadcast or? Nope. Okay.
Thanks, yeah.
I'm going to go ahead